Welcome back. We're in the second half of day 2 here at the Human Advantage. We learn from doing and seeing what works and what doesn't. That's the core of BVA's work in research and consulting, and a mission critical to uncovering the best use cases of AI. So we're going to jump into this next session and talk about experiments.
Yes, and I think we welcome John. John, are you there? Hi, John.
How are you?
Nice to see you. Good early morning.
Good. I got in on the airplane at about 2 a.m. this morning.
Wow.
I got a few hours of sleep, and now I get to talk to both of you. So you make my morning.
Okay, great. Thanks a lot. It is a great opportunity to have you live for our audience, because at the end of this presentation, they will have, all of our audience will have the opportunity to interact with you and to ask questions. So a big thank you for your for this opportunity, which is given to all. So John, first, we are thrilled and honored again to have you back at the Human Advantage Conference. During your two first presentation in 2022 and 2023, the level of appreciation of your presentation was amazing. People have loved your presentation. So the expectations, John, are very high this year again.
So it's either, John, 3 times lucky or 3 strikes you're out. We haven't decided yet. We'll vote at the end.
Exactly. I've noticed, Ted and Eric, I've noticed my time on the program has shrunk from an hour to a half hour. So
tells you everything you need to know. So John, for those of you who may not know him, if you haven't been here at the Human Advantage before, or if you've been hiding away from the experimentation of behavioral science and economics, is an academic. He's at the University of Chicago and the chief economist at Walmart. He's written a couple of books. We talked about the voltage effect last year, so I think you're familiar with that. Every time I see your books, John, it's either the European edition, I have the UK edition, and sometimes you show us the US edition, so we'll have to keep up. And John is considered one of the founders of experimental economics, and today you're going to hear him talking about a fascinating topic, which is Gen AI and experiments. Again, we've organized this session in 3 parts. First, John's going to give us a presentation, lasting about 15 minutes. Then we're going to have an interview with Eric and I, but keep your questions coming in the chat. I'm looking at Bertrand and Helene. They're capturing your questions, and they'll pass those to us so we can capture that at the very end. So, John, big thanks. The floor is yours. Let's see the presentation.
all right. I want to thank both of you for having me back. It's always so nice to be part of the public good that you're providing, and keep up the good work. I've been following along this year too, and it's been excellent. Okay, so let's get to it. I have 10-15 minutes. I want to talk about something that we've been doing both at Walmart and at the University of Chicago here to augment my own experimentation. So I'm thinking about experimentation in private settings, and I'm thinking about experimentation for academic audiences and for academic journals. So the way I want to plan today is I want to first talk about, what are our goals of experimentation? What's the aim of experimentation? And then I want to inject AI into those goals and argue that AI will be important to accomplish those goals, not only today, but also in the future. So my 2 studies that I'm going to draw from, wonderful co-authors, Gary Charnas, unfortunately he passed away earlier this year, Brian Jabarian, wonderful Frenchman. He's one of my postdocs here at UChicago. That will be one of the papers that I focus on. The other paper will be a paper that's not quite done yet, but it's coming very soon, I would say within a week or 2. And this paper is about 12 best practices for leveraging Gen AI. So yes, in 15 minutes, I'm going to try to put these 2 papers together and teach you the way I'm thinking about AI and experimental research. So what are those twin experimental goals? So I think, first of all, it's measuring causal impact, okay, but doing so with internal validity, but also determining relevant mediators and moderators. in an ethically responsible manner. So the way I want you to think about this is goal 1, or what I call EP1, you're learning about the effects of causes and the causes of effects in an ethically responsible way. Now, EP2 starts with internal validity from EP1, but then it goes to external validity and more. I want you to think about EP2 as you find a result in one setting, does it generalize to other settings that are, let's say, spatially, temporally, or scale differentiated? I want to point out the scale element is important here. And that's because that's, of course, what I talked about last time. I talked about scaling. Now, still today, scaling is what I would call disturbingly vague. It bundles many different concepts together. I want you to think about external validity as generalizing treatment effects. So when you hear that, I want you to think about treatment effects and do they generalize? When you're talking about scaling, this is the real concept that we care about in government, that we care about in private firms, that we should care about in the academy. It's really about generalizing benefit cost profiles. And that's how it's importantly different, but encompasses external validity. So you can say, okay, John, you have EP1, you have EP2. Within EP2, you have scaling, which we get is important. Now, how does AI fit in all of these things that you've just introduced? I'm going to say, in short, it fits everywhere. So generative AI, I think, when you break down the experimental, let's say, approach, you have design, you have data generation, and you have data analysis. Gen AI has a potential to make deep impact in each of those 3, let's say, experimental settings or 3 experimental areas. So the thesis for my lecture today is that Gen AI can push the frontier through novel approaches in design, in implementation, and in data analysis. And all 3 of those areas, the injection of Gen AI will enhance EP1 and EP2. So another way to think about it as well, Gen AI is lowering the marginal cost of doing research. That's a great thing on one setting, as I put over here, design, implementation, analyze, etc. But if we're naive about utilizing Gen AI, this could come with significant costs, and that's true. So throughout my 2 papers, when I talk about best practices, when I talk about best practices in design and in implementation, it's important to understand that Gen AI is not free. There are potential costs associated with using Gen AI. Now, in these 12 best practices, it brings out these potential costs. And the beauty of Gen AI is it leads to potentially vast marginal benefits. The dark side is potentially vast marginal cost. So within these 12 best practices, which weave between design, implementation, analysis, and where I see the future going, I have an eye toward both the benefits, but also the cost, and to try to curb those expected marginal costs. So let's go through some examples now. And where I want to start is a design example. Within the academy and also within firms. So before Walmart, I used to be at Uber, and then I was at Lyft as a chief economist at both of those rideshare companies. In both of those places, we oftentimes talked about things like the ethics of what we're doing. Should we be pre-registering? Should we be creating pre-analysis plans? These are very important new innovations within experimental economics. Now, the critics of this movement say it's so expensive to do these things, not only in a time sense, but also in a let's say resource sense. And because of that, you are letting the big players, the people who have large research accounts, they have an even bigger advantage because now you're making the barriers to entry even higher. I think Gen AI has a chance to significantly lower the cost of what I call pre-treatment chores. And in that way, it can really democratize science. Now, it also expands the information set of a researcher. And what I'm talking about is Gen AI is particularly useful to give some insights that even go beyond our economic theories or our social science theories that we write down, to identify relevant mediators. These are called mechanisms in the literature, or moderators. Remember, these were an important component of EP1. It also helps you talk about channels of causality that just due to inexperience you might not understand. I've been in the game for a long time, since the early 90s, so I have a really good sense about potential pitfalls, about potential mechanisms that maybe are outside the theory but happen a lot in experimental settings, whether it's in Walmart or in my academic research. Gen AI can have a particularly deep and welcome impact for junior scholars to understand these important missing channels. Now let's move from design to implementation. So here, I argue, and this is, I'm going to stick in EP2 here, Gen AI can help us a lot in what I call option C thinking. Before we get there, let's talk about what option C thinking helps to solve. And this goes back to my last year's talk, which was about the voltage effect. And the voltage effect is essentially, you find a great result in the Petri dish, and that's wonderful. You publish that paper, but then when you scale it up, the benefit cost profile becomes, let's say, in a sense, putrid, or it deteriorates. So the benefit cost profile looked great, and that's why you scaled it, but in the end, it didn't turn out so great. And that's what I call the voltage effect in my book. Now, we should think about what are some cures, or what are some approaches that we can take that can minimize this voltage effect. And this is what I call option C thinking. So this is a paper that I published in Nature a few months ago, actually. And what option C thinking essentially does is it flips the traditional research model, which is really one of efficacy. Let's give my treatment effects the best shot to be really big. It flips that by saying, what are the actual conditions under which my idea or my program will need to work when it's scaled? So in a way, it's flipping the general research model to say, let's look at the warts from the very beginning. And let's do so by using option C thinking. So I want to dig a little bit more into this, because I'm sure you oftentimes hear A/B testing, A/B testing. I'm arguing that we need to add option C thinking to A/B testing. But more importantly, given the title of my talk, Gen AI can importantly augment that type of option C thinking. Okay, so again, the analogy is to start with the big picture view from the very beginning and include some of that thinking in your original design. So some ideas that you might have is, well, what constraints will my idea face at scale that it doesn't face in the Petri dish? What are the key non-negotiables that can impact scaling? What are the mediation paths in the Petri dish? What are the moderators in the Petri dish? And are those available at scale? This is an incredible spot, because really option C thinking is curbed by our own imaginations, and this is where Gen AI can enter to really help our thinking. So at Check, this is an early childhood program that I started. We implemented option C thinking by hiring the assortment of teachers, let's say left tail teachers, middling teachers, and right tail teachers, to make sure that we developed a curriculum that can scale, because we knew that when you scaled that curriculum, we would have to hire a lot of left tail, middling, and right tail teachers. So we wanted to see if our curriculum could actually scale with that input changing. Data analysis. So Gen AI, I think, is going to open up a new track of thinking about replication and experimental power. So for example, for replication, a key point in that area is, did we do the instructions the correct way? Well, Gen AI can really help with standardization and SUTBA issues. These things can really enhance comparability. Now, of course, there's a blemish here because AI models do not consistently produce identical outputs with identical inputs. This is something that I argue we have to counter from the beginning. Create replication packages so replicators can reproduce their results using their own Gen AI tools, but also use this as an experiment in and of itself to understand what is the robustness of your results. Now, what about experimental power? Well, one key miss I see in papers today and at work at Walmart, and I saw this at Uber and Lyft too, is when people use regressions to model their experimental data, in many cases, they're missing out on using the baseline information effectively. So we've written this recent paper. It's with two co-authors, Ian Muir and Greg Sun, where we find that using the exact same baseline information, if you use ML techniques instead of the traditional linear regression adjustment, this allows researchers to gain the exact same amount of power with 4 to 8% fewer observations. So this can considerably enhance power of your experimental design. Simple ML tools. And you can see the code in that particular paper. So future considerations. I think the one potential blemish in the future that we need to be careful about is Gen AI is not a substitute for human ingenuity and innovation. It's really possible for us to get caught up in this thinking like a drone. And especially given the institutional pressures we have with publishing or producing product in the private space. What I really want to avoid is a science of homogeneity. Because if we get there, the beauty behind our science is the creativity and the creative people. We want to make sure that Gen AI augments creativity and celebrates it rather than curbs it. And then my last slide, so takeaways. I think to deepen the scientific knowledge, the stock of knowledge, I'm very optimistic that Gen AI in those 3 areas can augment the experimental approach in deep ways. Now, my optimism stems because experimentation, you have selective data generation. You can generate data in the lab. You can generate data in the field. You can generate data in a natural field experiment. Also, the ability to enhance replications. I think Gen AI will make a very deep impact in the space of replications. So we have yesterday's economist who visited the pin factory to write down economic theories and to give us insights about specialization and comparative advantage. I'm arguing in this slide deck that tomorrow's economist will continue to visit the pin factory, but will surgically use AI in field experiments to control the assignment mechanism, to tinker within the pin factory, not only to learn internally valid things about how the pin factory operates, but also insights within EP2, insights that can generalize and scale. So that's it for my formal presentation.
Great.
Thanks so much, and I'd love to take your questions.
So John, we have a couple of questions coming in online from some of our attendees. I'm going to ask you kind of 2 questions that I think are linked. The first question is, how do researchers ensure that the use of AI in their experiments does not introduce new bias or errors? Any best practice? And linked to that, someone asked, what are the tips to test the actual performance of Gen AI according to data quality?
Yeah. No, I think that, let me start with the second question.
Sure.
The data quality and the data privacy, these are 2 features that worry me the most. Mm-hmm. I only had 10 or 12 minutes, but I wanted to focus on the positives sure. of Gen AI and the opportunities of Gen AI, because I think the opportunities are great. I think in the area of data privacy, there are real issues, and one of the best practices In fact, best practice 2 in the paper is disallow public AI model training on imputed data and ensure that AI platforms have adequate data privacy measures. I don't think many of them do right now. We have to take great care before feeding those training models data that might impugn on our promise to subjects. Our promise to subjects is in an ethically responsible way. We're generating data, and that includes data privacy. So I think that's a very important hurdle that many of us are currently grappling with, but it's certainly first order. In terms of errors, you're exactly right. There might be errors, and errors of a different variety that we've never seen before that arise because of the new use of this new technology. And when you hear Gen AI and ML, there's a basket of different things that we're talking about. And I think there you constantly have to experiment and do robustness tests and explore how far reaching are your particular results, and how confident can we be that we haven't introduced new biases.
Another question we have, someone's very on brand today. They said, what's the human advantage that AI won't be able to learn? You know, is there something that we're retaining as human researchers? You kind of alluded to that, but anything that sticks out in your mind?
Yeah, I do. I think the human advantage to me is creativity and thinking out of the box. And when we forecast out of sample, we don't really have functional forms that we restrict our thinking. We're very nonlinear thinkers and very different thinkers. I think that aspect is really important. In fact, I think one of the best practice number 12 is Gen AI is not a substitute for human ingenuity and innovation, and at least today. And I'm optimistic for the human species to continue to have that comparative advantage. So I think the human advantage, of course, is augmenting and using these tools to make the world a better place. And I think making the world a better place through experimentation is to augment our learnings through EP1 and EP2. But that right now, in my vision, is not going to be curbed out by Gen AI unless we let it. But in that case, we're becoming a science of drones. And I think that would be an unfortunate place to end up. And I don't see us ending up there.
John, another question. How can smaller organizations with limited resources effectively integrate AI into their experimental process? How they can do this?
Yeah.
Are these affordable or accessible solutions available? Or any advice from you?
No, that's a great question. I would say yes. I mean, let's just think about my point on data analysis. Gen AI can really help a smallish firm, a small government, let's say a resource-constrained organization, because it allows you to, let's say, attain much deeper experimental power with a smaller information set. With, a lot of times people say, I'm a small firm, so I can't run experiments because I only have a small number of customers or providers or data points. Gen AI now opens that up, as I mentioned, because once we have that in place, we're significantly enhancing our experimental power. Now, part of your question also is the human capital strong enough in these small firms, or does Google and Walmart and Uber and Lyft, do they have such deep pockets that they hire all the best human capital, and the smaller firms are left with human capital that can't use these types of tools? I don't think that's right. I think that we've democratized this approach enough where if you understand how to use Stata and understand how to use Python or R or some simple languages, I think you can use these off the shelf. People like me, when I created that paper that I mentioned, the paper that's forthcoming in econometric reviews, the code is there. So all you need to do is copy it into your program of choice. And you have a chance to now reap those gains that I'm arguing are up to 10% of gains in experimental power. So high schoolers can use my particular approach because they understand how to load stuff into MATLAB or Stat or Python or whatever. So I think it's actually democratizing in a very great way. But we should also make sure that when we create, that we allow others, everyone, to have a chance to use it, because we're really all in this game together, right? We're trying to generate insights that add to the stock of knowledge that can then help change the world for the better.
Yeah. John, we have a lot of researchers, data scientists, insight managers, et cetera, in our audience at the Human Advantage. What training or skills would you recommend that researchers, maybe they're not in an academic lab, but they're, the type of people who are working in private enterprise as you do, to develop, effective use of AI in their work? Any resources, programs you'd recommend, or a mindset or some skills?
Yeah. That's a great question. I think if I was a firm, I would think hard about partnering with an academic or set of academics. And the reason why I say that is because there are dramatic gains to trade that are foregone, because on the one hand, we have a lot of academics who are just chomping at the bit to work with private organizations or to work with government, and they're willing to provide their labor, quote, for free. Now, what I mean by that is they want to work with your data, and they want to get a sense of what they can learn and write it for an academic paper. So if you have some academics embedded in organizations who will supply their labor for free, and you have an organization who has a great platform, but they just don't have the human capital, you have serious gains to trade by the organization partnering. And partnering also with people like all of you, and to have all of you put your human capital and your knowledge inside that firm. And I think these partnership opportunities to diffuse the technology is a pretty easy way, and it's turnkey, and you can do it tomorrow. The longer term view is to take some classes. There's some great people out there, Scott Cunningham and others, who are teaching knowledge courses, and they're trying to teach knowledge courses to push this idea of we're entering a knowledge economy. And in that knowledge economy, it really helps to have information and to be able to use these deep insights from these new literatures. So I think a course or two there to augment your human capital can help a ton as well.
Can I ask another question?
Please.
It's got a lot of votes online. John, do you think there's a role of Gen AI for predicting experimental results by simulating participants? The implication being you can quickly narrow a long list of treatments into a shorter list of promising ideas to test in reality. Any sense
Absolutely.
of that?
100%. I think John Horton and others, and there are other people thinking about this too. I think your audience is a very smart one. Absolutely. But that does make me worried a bit, because within EP1, when we generate new insights, we always have to make sure that these are original and honest insights. What I worry about now is the credibility of our research. Is this data set created by Gen AI, or is it created by humans who have been part of an experiment? And I think when you start viewing through the lens of these nefarious characters, that can't happen in our science. The minute we lose the trust and integrity of decision makers that we're creating real insights, I think we're in trouble. And that's a part of the best practices, that we need to take great care that the data that people are generating are actually true data. And look, the behavioral sciences and the credibility revolution has gone through this, and we all know about data colada and what happened with those researchers. And those are real threats to the foundation and integrity of our science. So I think it's a very good idea to use it to curb ideas. And this is what I was talking about with option C thinking. In a way, what you're doing is you're figuring out what are the best treatments I can use within my theoretical model predictions that Gen AI thinks can work the best. And now I'm going to pilot those and I'm going to see, and then I'm going to go ahead with my experimental design. So again, I think there are dramatic and deep benefits in not only pruning for EP1, but also doing it with option C thinking. But there's this dark cloud that we have to make sure that we are policing and replicating and making sure that these are true scientific insights that we can take to decision makers and call them actionable.
Yeah. Great.
Thanks, John. It was again, I think your challenge is successful. And I do recommend to our audience to read this fantastic book, The Voltage Effect, which is about innovation and how to be successful at innovation. So, thanks a lot, John. Hope to see you in person at a moment, and have a great day.
Great.
Thanks, Eric
John.
and Ted, thank you so much. Thanks for having me. You're always a delight to talk to. Whenever I see both of you, I smile. You make me happy. So have a great day. And thanks a lot, everyone, for tuning in. Keep changing the world using science.
Great.
Thanks,
John. Have a good
Bye,
one.
John.
Bye-bye.